Hello friends, welcome to Byte Big Data. We are going to see in today's tutorial how to install 3 node cluster using Hortonworks HTTP 2.5, and we are going to use uh, Docker for that. So this is basically, will get you some hands-on on Docker, that how we can use Docker containers in order to create a 3 node cluster within a same single VM. Okay, so let's discuss the architecture first that we are going to use in this particular tutorial. So we will have our base Windows machine that I am currently in. So I will write it as Windows machine, and we will create a virtual machine inside Oracle VirtualBox. So this is my VirtualBox. So this is a tool basically that will provide you the facility of doing virtualization on your machine, and using this you can create some different operating systems on the base operating system. So this is just like create some uh, virtual machines on base on the top of your physical machine. So we are going to create we are going to install one CentOS operating system over here in the VM, in the virtual box. This is going to be my CentOS 7.4. So in this CentOS 7.4, we will use this machine as a base machine, and we will install Docker in this, and we will create containers of Docker in order to create our slave nodes. So if you if we see the architecture at overview level, basically we are going to create two containers. One is container 1 and another is container 2, and these both containers will be created using CentOS 7.4 Docker image. Okay, so when you think about Docker, basically so this tutorial does not give very in depth of that what Docker is. Basically we are going to directly do hands-on on using Docker to create a 3 node cluster. So but on the overview layer, basically Docker is like basically a cloud in which like we will have lot of very small size operating system images. So you can create Docker image of CentOS, or different Linux flavors, or Windows even, or any free operating systems available. Okay, so that will just provide you very little or very small size images that you can use, okay, as a base image, and then later on whatever extra softwares you want to install in them, basically you can just update that image to have the extra softwares. Okay, so from this Google so from this Docker cloud, basically we are going to pull the image of CentOS 7. Let me just change the color of. So let's say this might be the 7.4 CentOS image that we are going to pull into our VM. Okay, and we will have a base image of CentOS over here, and we will add few more softwares, though those are required for installing our Hadoop, and we will create two containers out of this Docker image, that is container 1 and container 2. Okay, and these container 1 and container 2 will be serving us for our two slave nodes, slave 1 and slave 2, and our master, that is the where we will install all our masters, basically will be served by the CentOS base 7.4 image. So I will say this would be my master M1 image, and then this would be my slave 1 image, and this would be my slave 2 image. Okay, so this is the overall architecture that we are going to create. Okay, starting from the installation of CentOS 7.4 from the scratch, and we'll see that how we can perform that on the virtual box. And once that CentOS 7.4 image gets created, we will pull the we will pull a Docker image of CentOS 7.4, because we require our both master and all the slave 1 and slave 2's operating system to be the same. Okay, so once we get the Docker image for CentOS 7.4 in our base image, base VM basically, we will then create the containers out of it, and that container would be C1 and C2. Okay, and within the same machine basically, that is, if I just draw this green boundary, basically this is going to be my 3-node cluster within the same VM. Okay, so I need not to create multiple VMs just to create slave 1 and slave 2 also. Okay, so within one VM basically we do have all the three nodes basically, just to create a 3-node cluster of Hdp 2.5. okay, now basically what we are saving here, or so due to the use of this Docker facility, or this Docker containerization, or Docker containers basically, in order to create our slave images, or in order to create our slave nodes, we are actually saving some of the memory, okay, that would be rather used by the what we can say is, when we install any Linux operating system, basically it uses a kernel at the bottom, and that kernel uses if you install full OS as a separate VM having the kernel also, basically it will occupy some of the RAM. Okay, and it requires like more RAM to run. So we are actually saving that amount of RAM, maybe like 1 or 1.5 GB per container when we are using Docker. So let's say slave 1 we are saving 1.5 GB of RAM, and then on slave 2 also we are saving 1.5, so around 3 GB of saving of RAM basically we are trying to do, or we are trying to save over here. Okay, suppose if you are installing this 3-node cluster in your machine where you do have either i5 or i7 processor, and then around 16 GB of RAM. So basically, if you really want to create a model, or if you really want to create a 3-node cluster having separate VMs installed on your virtual box, each of those VMs may require around 5 GB or 4 GB of RAM individually. So if you just combine them, 5 plus 4 plus around 3 or 4, basically it comes around 12 GB to 13 GB. And just to give you the performance, just by installing few of the basic components of Hadoop like HDFS, Yarn, Hive, and just that, not the whole component, not the all components. So basically we are going to save around 3 to 4 GB of RAM just by creating this model, in which we can just run this whole CentOS 7.4 under 7 to 8 GB of RAM. Okay, so let's begin with the installation of CentOS 7.4. So I am having this virtual box running, and I will just say I will just create one image called CentOS. I will say Docker. Okay, so this is going to be the image, and I am going to select Red 64-bit with Linux, and then I am doing next, and I will put this memory around 5 GB. Do next. Create a virtual hard disk, so just let it be VDI. So this tutorial is not mostly like how you install CentOS. We are just like creating the CentOS 7.4 image. Okay, so these are like some steps that you need to follow in order to create the CentOS 7.4 image. So I'm going to do next, and then I will allocate around, let's say, 60 GB of hard disk. Okay, I'm not going to modify, or I'm not going to put any boot or root or swap partitions, and I will just use the default partition that will be created to install this image. Okay, so I'm saying create. Now I will also set the networking on it basically. So the networking I'm going to select as host only for the first adapter, and for the second adapter I'm going to select NAT. Okay, the difference between these two is basically when you do host only adapter, you can just set the static IP, okay, that will be assigned by our virtual box, okay, and this NAT, through this basically we are going to get the internet facility available to our virtual machine, so that we can download certain online packages. Those will be required during the installation. So that's it. I'm just saying okay, and I will start it, and I will pull I will give it the ISO of CentOS 7.4 from where the OS will be installed. So I will just bring it down. So this is my uh, folder or directory basically from where I have placed the ISO of CentOS 7.4. So I will just select it, open it, and I'm now doing start. So this we will try to install only the base image. I am not going to install any desktop of it. So let me just be in a scaled mode, and I will just make it more bigger. Okay, so I will say install CentOS 7. So if you really want to download the ISO of CentOS 7, just Google it, or go to the CentOS website and try to search for ISO download of 7.4. So that would be the latest available. So you can just bring it. So this is going to take some time. So we will first allow it to install all the packages. So during the installation of all the packages, basically it will take around 10 to 15 minutes. During that time, I will pause this video. Okay, so I'm going to say English. The date and time I'm going to select India. I will say okay, done. Language is okay. Installation source, that is okay. Installation destination. So basically this is the amount of hard disk that we have chosen the size of hard disk at the time of defining the hard disk. Okay, so let it automatically configure the partition. So we are not going to do it manually. Otherwise we could have chosen, like, we could have made our own swap partition, root partition, boot partition and all. Okay, so I'm just going with the automatic partition. Then go to network and host name. So these two are, we just need to remember this ENPOS3 and ENPOS8. So this ENPOS3 is going to be our host only adapter, and ENPOS8 is going to be our NAT adapter. Okay, and let me change the host name to master2.cluster.com. Okay, so this is going to be the name of my machine, that is the base machine. So I'm saying done, and rest everything seems okay. Security policy, you can go, and later on we need to do some more certain modification in SSH, Linux and all. So basically let it be. I'm saying done, and I will just begin installation. Okay, let me just set the password, root password. So let me put my name, MIMANT. Okay, done. And I will create a normal user, MIMANT, and the password is also same, MIMANT. Done. So it is going to take some time. Around 298 packages is going to install. So I will pause the recording till then. Okay, now the CentOS is installed. Let me just reboot it. So once it gets rebooted, we just need to put the root as user and Mehman as password. So basically now what we need to do is we need to first check if the internet is working or not. Okay, so let me do ping www.google.com. So currently it's not working, so we need to set up the networking for it. So for that we have two adapter, right? We had set while installing the CentOS. One is ENP0S8 for NAT and ENP0S3 for host only. Okay, so for that we need to go to etc sysconfig network scripts, and here we will find, so currently I cannot download it, so it should be ifcfg03. so this is for host only. Let me open it, and we need to do certain modifications here. The first thing is we want it to be static, so that whenever we restart our virtual machine, it should not have the new IP address every time. Okay, so we need to make it static. Second, we need to while our CentOS gets booted, every time reboot basically, till when it is getting rebooted, then it should get the new, it should assign the IP address. Okay, so it should be on boot, yes. Okay, then we need to provide IP ADDR, that is the IP address that we want for this machine. I am giving it 192.168.56.131. so this last digit can be anything. If you install VirtualBox on your machine, basically you can check the range from, if you go to CMD basically. So here you will see, if you do ipconfig, basically you will see that what is the host or the virtual. So whenever you install VirtualBox, basically it install its adapter. Okay, and this adapter is this, so that is what is called Ethernet adapter for VirtualBox host only network. Okay, so the IPv4 address, that is the Internet Protocol version 4 address of this adapter is 192.168.56.1. It means that starting from 2 to 254, you can generate those many IP addresses in this series. Okay, so here you need to look into when you try to decide that what should be the static IP address for your machine that I am giving here. So this first 3 octets should be same. Okay, just like this 192.168.56. okay, this is coming from host only, and from 2 to 254 you can assign whatever you want. Okay, so I have chosen 131. Then I need to provide net mask, that is 255.255.255.0. this will tell you that this will actually provide you that this is a class C network, and we are going to use it. Okay, so this is the modification that we need to do for ENP060S3. so I am saving it now. Then we need to do similar for 08, and here DHCP is okay, and I think we just need to put on boot yes. Rest everything is okay. I'm saving it, and once you save it, I'm just clearing the screen, and I will just say system CTL restart network. Okay, it's done. Now I need to ping www.google.com, and you see now the internet is working. Okay, and if you want to check the IP addresses of all the adapters that we are currently having on our virtual machine, so you just need to do IP-ADDR, and you will see that there are 3 IP addresses associated. One is by default this loopback 127.0.0.1, this one. Then we do have the Ethernet ENP0S3, that is 190.168.56.131, and then we do have one more, that is 10.0.3.15. okay, that is coming from NAT. So once we do that, basically we are good. We can open putty session from here and connect to our virtual machine. So the address is already being there. I'm just updating the key since I had already connected to it in my previous attempt. So this is user ID and this is the password. Okay, let me just make it bigger. Okay, so once you connect, basically now this machine is ready for doing so if you see the architecture, basically our CentOS 7.4 machine is created, and we just need to modify it further in order to make it suitable for installing the HTTP 2.5. okay, so there are a few things those are missing yet in this machine, and we are going to install few of those services one by one. Okay, so we have verify our IP addresses, they are running fine. We need to install HTTPD. Currently it is not there. So HTTPD is a service basically that will provide you the Apache web server in which you can create your own local repository. Okay, so I'm just installing it. So it will first update yum, and then it will start installing it. So let me pause it because it will take some time. Okay, so my yum is refreshed basically, and now it is allowing me to install HTTPD. I am saying yes. And yes. So my HTTPD is installed, and I just need to start it in terms. So I will run this service HTTPD start. Basically, it will just route our thing to systemctl command only. Okay, and we also need to put it enable. So this is the way you will just enable it. So it should be running all the times. Okay, so you can just check its status. Service HTTPD status, and currently it is running. Okay, so you can also verify just to hit it from the web browser. You can hit it from Windows because you are now able to see this IP address. You just need to hit this IP address and it should give you some Apache web page. Okay, so currently it is not giving because we need to off the firewall. So just let me close it. So I will first off my firewall. So this is the command through which you can just stop the firewall and then make it disable permanently. Okay, so once you disable it, if you now hit this IP address, you should be able to get the web, so this is our Apache welcome page of our HTTP server. Now the home directory of HTTP server is cd/var www.html. So this is the home directory of our HTTP server. Whatever you put inside this directory, basically over here, though that will be visible on the web browser. Okay, and this is the place where we are going to keep our Hdp2.5 repository, okay, that we are going to use in order to install the Hortonworks. Okay, so let me do that. So I have that repository available with me over here. So inside this HTTP 2.5 repo folder, I do have Ambari HTTP 2.5 and its utils. Okay, so I will just connect using WinSCP, and I will just copy this whole repository over there. So you can download this HTTP repository, HTTP 2.5 repository by connecting to Hortonworks, and you can just Google it out that how to download the whole tar.gz, that is complete package, complete RPM package of HTTP 2.5. So you can have it for like HTTP 2.4, HTTP 2.3, HTTP 2.6 as well. Okay, so this right side of this WinSCP is actually from the Linux side, and the left pane or left side is basically from the Windows side. Okay, so we need to set our directory to be /var www.html, that is the directory of HTTP home directory. And so I have set up the HTTP home directory over here, and I just need to get it from so I'm just pulling this repo over here and dropping it here. So this will again take some time in order to copy, because it is around like 4 GB of total data of repository of HTTP 2.5. So I will just pause the video till it gets completed. Okay, so we have copied the whole HTTP repository over here. So now that is visible. If you go on your web server and try to say repo, so we do have our working local web browser or HTTP repository of both Ambari and HTTP 2.5, right? So this we are going to use in order to do the installation. Now this part is over. Basically what we need to do is we need to now set up two things. One is Docker and one is Ansible. So as of now in this architecture, basically we have created CentOS 7.4 image with the HTTP 2.5 local HTTP repository available. Now we need to install Docker so that we can create these two containers, C1 and C2, and we also need to Ansible so that we can configure them as per the requirement, depending on like whatever is required by the installation. Okay, so let's do it now. So I will just say sudo yum install Docker, So let it download. Okay, so the Docker is now installed. We need to install Ansible after this. So that is the next step. So let it complete. Okay, so we have installed Ansible also. And now we just need to start Docker. Okay, so once the Docker is started, we can pull the image by using some Docker configuration. But before that, this wget, this is the utility to pull, to download something from the website. So this is the Linux way of getting the things from online. So currently wget is not available in this environment, so I'm installing it. And we are going to install MySQL. So basically this is the RDBMS, and this MySQL will be required by most of the Hadoop components like Hive. You can also use this MySQL RDBMS for Ambari. So all these components basically keep their metadata in this MySQL. Okay, so it's like, since it is free, we can use for our demo purpose. So I'm just getting the RPM of MySQL and now just doing the installation of it. Okay, so it's getting installed now. Now we need to disable the cell Linux. So for that you just need to go to etc this cell Linux config, and this needs to be disabled. So cell Linux should be disabled, otherwise it will block some traffic. So I have disabled it, and then we need to change the hosts file. Okay, so etc hosts, and here we need to put all the hosts name. Okay, so my base machine, that is the current machine, its host name, so IP address would be 192.168.56.19.31. So 192.168.56.131, it would be master2.cluster.com, and its SQDN name is master, and its FQDN name is master2.cluster.com. The other two entries also we need to add, and it would be for slave 1 and slave 2, that is the other two nodes that we are going to have. And the IP address for them is not from this series, because when we install Docker also has installed its virtual adapter. So let me just show you that, since we have started Docker, so we should be able to see it. Now if you do IP ADDR, so here you will see that this is coming from Docker. Okay, so we have installed the Docker and we have started its service. So basically this is the range of IP address 172.17.01. So this is completely different subnet from this particular IP address. Okay, but since they both are linked together within the same machine, they can easily visible to each other. Okay, so suppose within this same machine, if I'm going to hit ping to this, basically it should be working, you know. So currently we are going to hit it. So but this is completely different subnet, and this is completely different subnet. But since they both are on same machine, we can, you know, ping to each ping them, or they are actually visible to each other. So what we are going to do is basically we will. So this is the, what we can say is, this particular, this would be the like adapter IP address, and we are not going to assign it, assign it to any of the Docker containers. So we are going to start with 2. So 172.17.0.2. So from 2 onwards, we can assign the IP addresses or the series of this IP address to different different containers. Okay, so because this is a kind of a gateway IP address for the Docker, you know, the Docker adapter. So what I will do is I will copy this, and we can change this to 2 and assign it to the first container that we are going to create. So I'm going to assign, or we will be, you know, providing the name to that first container. Docker container will be slave1.cluster.com, and its SQD name would be slave1. Similarly, the second container would be slave2.cluster.com slave2. Right, so we already have now done this configuration, and the same etc host file should be available to these 2 containers, Docker containers. Okay, so let me save it. So I saved it now. Then we need to install NTP, that is network time protocol, that is not also available in my CentOS 7.4. So let it install, and we need to start and make it on permanently. So this got installed, make it on, and enable it permanently. So this is done. We have done the basic setup of our CentOS base image. Okay, this is the requirement. We require it when we do the Ambari installation. So just leave it for later time. Now this is the base configuration that I am going to copy, and I will just explain this. So I am going to create a file called Docker file, and we'll copy this thing over here. So this is actually define the configuration when you are going to pull the Docker image from the Docker cloud. So basically when you say from CentOS, so it would refer to the latest image available on the Docker cloud for CentOS. So most probably it would be say CentOS 7.4 only. Now maintainer, you can put your name over here. Okay, the environment is going to be the Docker container, and once you get this image, basically once this image will be done, so this image would be very lightweight image, around 75 MB of total size. So once it gets downloaded, basically within that image, basically we are going to perform these operations. Okay, so we will need yum update, so all its repository will be refreshed, then we will clean it all, and then install these 2 things. System ed. So this is basically is required for running certain commands like IPADDR and few more things. Okay, and then these are some temporary files. And finally, when this container, or whenever the containers get created from this image, basically the default login directory would be user has been in it. Okay, so you will get a command prompt from whenever you log into that container. Okay, so this is very simple and basic configuration of the Docker file. So I'm going to save it, and now we need to pull the image from Docker. Okay, so this is the command that you need to run, docker build. So if you say Docker, basically you will get a lot of sub commands that you can run on Docker. Okay, so these are all commands, and with certain options on each command, basically you will go further down. So this will basically, give you kind of a very virtual environment on the top of your virtual machine, and you will come up with like more containers uh, using this. Okay, so you will you just need to do some kind of hands-on using all the options around it. So we will see few of them during this tutorial. So I'm going to build. So this is the first option that we are going to look at, Docker build, and then we are going to, so this would be the name of our image, new Hadoop image. I'm just, so you can just put whatever arbitrary name you want, and whatever is the configuration written in this Docker file will be applicable, will be executed basically, and then this new Hadoop image will be created as a Docker image. Okay, so I am going to run it now. So it will download around 75 MB of image of latest CentOS from Docker Cloud. So it will take some time. Okay, so our Docker image is pulled now, and the image is created. So basically, let me tell you what has happened as of now. So we have run this command to build the Docker file. Okay, so whatever is written in this Docker file will be executed during this. So when we say Docker build, this RM will remove all the intermediate images. So basically, when you see this Docker file, we first pull it, and then we do this kind of changes in it, right? So we are updating it, then we will clean it, and then we will install few more things. So in every of this step, basically it may create some intermediate Docker images, right? So those will not be needed. So those will be kind of a temporary images that we should not put in our system for longer time, or we should not put it for permanent time. So basically it will remove all the intermediate images that will be created before your final image will be generated. Okay, so it has executed all this. It has pulled. So it pulled around okay, so it has pulled it from the Docker Cloud, and the total size, it was around 73 MB when it was showing it, and then finally it has run all that cleanup and install and update complete yum in that, and finally it has given us this message called successfully built it, right? So you can just say Docker images, and you should be able to see that our image has built, that has around 279 MB of total size, that is the installed size basically. Okay, so when it got downloaded, it was around 73 MB, and some more things got added into it during the installation, and finally we have got this running size. Now this is the image that is the base image, that is new Hadoop image, that is the Docker image now, and we need to modify it further in order to add few more softwares in it, in order to make it suitable for installation, or to make it like slave nodes of our Hortonworks HTTP cluster. So what we need to do is basically we are going to create one more Docker file. We could have added this. I mean, if you do it on your system, you can also you can just add this in over here in the previous file over here, that is run yum update. So you can just put all this thing, but since I have first made that image and then I need to further modify it, so I'm doing it now. So what I will do is I will create one more file, new Docker file, and then we are going to, now we are not pulling it from the Docker cloud now because we do have it locally available called new Hadoop image. So this image we have just built in the previous step. Okay, so we are going to use this the image in previous step, and we will further modify it to suit our purpose. So I'm just now doing it and creating one more new image called this image. It is called Hadoop image now. Okay, so it will again take some time. Okay, so our Hadoop image is now built. That is the new image. So we had used the previous image in order to add few more softwares into it and created our new image. Now if you do docker images, basically you will see that this is the latest image that is with us now. So if you see the size, we have like added few more softwares in it to make it more suitable for installing HTTP. Now these are some utilities that we had added. So it is OpenSSH server clients. Okay, these are required for creating some because the OpenSSH was not there, so it is required just to create a passwordless SSH for root user. Then we have installed some net tools in order to run some IP ADDR command. Okay, so these are some basic utilities. Maybe you may require more when you try to do more things out of that container. So you can add you can create further more new images after adding few more softwares to it. Okay, so this you can keep going, and then your size of container or this image keeps growing. Now once we do that, we need to start two containers. So this would be the container 1 and this would be the container 2. Okay, now if you see, it says this docker run privileged. Okay, now this will actually it will tell you that we are going to use this Hadoop image, that is the latest image that we had created, right? So this is the image that we had created. Now we are going to create a container out of that image using all these options. Okay, so we are going to run a container out of this Hadoop image that is we have created, and the name of that container would be slave1. So that is the name of our that would be the name that we are going to give it to. And here we are actually giving its name slave1, and we are also providing host name to this container, and the name of that host name is slave1.cluster.com. So basically whatever host name we are going here we are giving here is going to be added. So this is going to be the host name of your container, and this add host will be these 3 entries. So these 3 entries will be automatically added into the etc hosts file of this container. Okay, so we want this to be identical with our master, that is we have just created. We had created like over here in our etc hosts file. So we want these 3 entries to be identical in these containers, slave1 and slave2. Okay, so we are providing this directly on the option over here while running the docker. It will be automatically added into the etc host file of this container called slave1, and this is the volume basically. Okay, so when we pull the things, we have defined that this is going to be the volume associated with the hard disk, you can say, for this container, and it is going to be created out of this image, and the default command line, so it would be user has been in it. Okay, so this is like the basic basic command to create to create a container using image of Docker. So I'm running it now. So it will create, though it will you just need to verify Docker that is a list of containers. So let me just run it, docker ps. So it is saying that currently it is up and running slave1. Is it? Yeah. So it is it is saying that up 25 seconds. So currently when you when you issue this command, basically it will start running the container at the backend. So that will now tell you that slave 1 is getting running, right? So if I do control C, so now if you do docker ps, basically there is that particular slave 1 container image that was running now got stopped, but then it got created basically. Okay, so we just need to issue the name of that container and say start it, and it will start running. Okay, so now we need to do the same thing for this slave 2. And the beauty of this is basically you can add, you can start as many containers you want with this different names and provide all the configuration that you want to pass from the command line itself, and that container will have all that configuration you want. Okay, so you can start hundreds of containers like this, okay, within the same VM. So now I am starting the second container, slave 2. If you do docker ps, you will see that slave 2 is now started and running for like almost 9 seconds. Let me stop it. Okay, now if you see docker ps, basically we do not have any containers running because we have just started them and then stopped them. Now before so now we can restart them again by issuing this command called docker start slave 1 and docker start slave 2. And if you want to go into that container in the command line of that container basically and do something within that container, basically you just need to issue this command called docker exec. So it will execute the command in the docker container. Okay, so now we are like almost ready for using this container in order to make them the slave nodes of our cluster. But before that we just need to configure the Ansible so that okay, so before that we need to create a passwordless SSH, or first we need to, let's say, create SSH keygen. Okay, and then we need to create a passwordless passwordless login for the root user on master, that is this master2.cluster.com, and for slave 1 and slave 2 also. Okay, so let me then start the container. So I will say docker start slave 1 and docker start slave 2. Both are started now. If I say docker ps, it will tell me that okay, slave 1 and slave 2 containers are running. Okay, can I ping them? Yes, I am pinging. I am able to ping them. The slave 2 also gets pinged. So our master 2, that is this host name, master2.cluster.com, that this machine is actually this machine is able to see these slave 1 and slave 2. The docker containers are visible to our base machine. Now we need to so we have created passwordless SSH. We just need to copy, I will say SSH copy id -i SSH id rsc.pub. So I'm going to copy into master 2 first. Okay, so it says SSH copy id is equal to master 2. Okay, so basically it was not working because I did not have the proper name in vi etc host for the SQDN. So I have updated it now. So if you see now, my SQDN for this machine is master 2. So now I will rerun this command and I will say yes, provide my password for the first time. If I do SSH master 2, basically it should not ask the password now. That is perfect. Same thing we need to do for slave 1 and slave 2. That is, the slave 1 container is running off docker. So I am saying yes, giving password, and it says okay, permission denied, please try again. Okay, so it says permission denied, means we are not able to, you know, access. So let me just go into slave 1. And let's see if the directory is there. So we can create it as SSH. Okay, so what so basically, you know, the .ssh is under the root. So if you go to slave 1, that is root at the slave 1, when you go into the container and come to this directory, basically you can create one file called authorized keys. And put the public key in it. Save it. Now let me try to log in SSH slave 1. Okay, so I am able to log in slave 1 without giving any password. Okay, so we had a permission issue. The root user from the master2.cluster.com did not have the proper permission on the slave 1 basically, and that's why we could not copy the public key and it could not create the authorized key. So we have just manually done it now, and if I try to just log in into SSH slave 1, so without asking any password, it is now doing the same thing we need to perform on so let me exit out of it. We need to perform same on slave 2. So I will go into slave 2 and I will go into cd root and .ssh. Currently I do not have, so let me SSH keygen here. Go to root .ssh and create authorized underscore keys and insert idrsa.pub. Save it. And now try to do SSH slave 2. Okay, so it is again, so we have created the root passwordless login for the root user on both slave 1 and slave 2 container. That is a Docker container. Okay, so I am able to log in now. So let me out of it let me just try to do SSH on master 2 itself. So yes, so now from this master 2, basically we have created the passwordless login to the master 1, that is M1, the same base machine, and then slave 1, S1 and S2 also. Okay, so we are almost done. Now we need to just set up the Ansible vi/etc Ansible hosts. So this is the host file of Ansible. If you go to the bottom, you can just create the, so I will say master would be master2.cluster.com, and slave to be slave1.cluster.com, slave2.cluster.com. Right, so this is my master machines, these are my slave machines. Okay, so we can do the configuration. So if you make some configuration on your base machine and want you to and you want to flow, you want to send the same configuration to the other slave machine, basically you can use this Ansible. So Ansible is basically agentless utility that will allow you to configure multiple machines simultaneously. Okay, and it is very lightweight basically, and it is like getting used heavily nowadays in productions. Okay, so let me save that. Now just to check, you just need to say Ansible, and you can select the module -m, I will say ping, and I will say master. Okay, so basically it's on the reverse way. So I'm just trying to check if the ping module is working. Okay, so what it says, Ansible master ping, I will say yes. So the ping, so Ansible is now able to see master. Let me just try to ping both the slave machines one by one. So I will say yes. I will say yes. Okay, so both my master machine is visible to Ansible and slave machines are also visible to Ansible. So I will say, let me just retest it. So I will say Ansible, and instead of both I will say all. Let's check if it works for all the machines. So yeah, so we should be we are able to ping master 2, slave 1 and slave 2 also. Okay, now there are certain ad hoc commands we can run through Ansible. Basically we can, because on both our slaves we do not have NTP, so first we need to install them, and then we need to start them, as well as we need to have them on for all the time. So NTPD would be started as well as enabled for all the time. So let me just run these two ad hoc commands that will apply on both the slave machines. Okay, so I have run both these ad hoc commands of Ansible. So this actually runs the yum module of Ansible, and this yum module will help this NTP to be installed on both the slave machines, as slave 1 and slave 2 containers, right? And we need to pass sudo because it requires sudo user to install the things, right? Now and then after that we need to just make this NTPD on, and we need to make it enable for all the restarts. Now I will just give you one very quick example of creating a playbook of using Ansible. Okay, so what you need to do is you just need to, the important thing here is basically it requires the syntax. Okay, so because it's .yml, it requires the syntax. You cannot just this is how you need to write it. So you have 3 days, then 1 dash, and then hosts, and then colon, and you need to just like write the things one after the other, and one under the other basically. Okay, so in this playbook, I will just copy these lines and create a playbook. In this playbook, what we are going to do is basically, so NTP we already have done. Okay, so this does not affect, but we need to copy the say Linux. So currently we did not do any say Linux stop configuration on our containers, so we will copy this from master to our containers. And we are also going to install some this Python certification. So basically in this 7.4, basically while installing the Ambar, it will give some kind of the certificate verification. So we first need to do that on our base machine. So I will just go here on our master 2. Okay, so this was done actually. If you see the Docker installation or Docker ad hoc commands, so it has first installed NTPD, and then it has started them. Okay, so this is the output that it should like. It should look like. Now let me go to this particular file and make it verified disable. Currently it's like platform, so I will just remove this and make it like this, and let me save it. Okay, so same thing we need to now copy to the other two nodes called slave1 and slave2. Okay, so for that we do have this Ansible playbook, and it will do the magic for us. So I will just create a playbook, and I will name it as anything. I will say setup .yaml and copy it, save it, and now run it. Ansible playbook, and the name of that playbook. Okay, so it will do the rest of the things. Okay, so it has installed. So basically whenever you see this that yellow thing, it means that it has changed something, and this green means it did not do any changes. It was already like that only. So just like since we had run the NTP installation and NTP start and make it enable with our ad hoc Ansible commands, so while running the same thing in the playbook, it did not make any difference. And so Ansible will keep a history of whatever it has done and whatever, so it keeps monitoring the changes made in the playbook somewhere or in the configuration. And if it finds that okay, there is a mismatch between the configuration from the source and the destination, then it will do it. Else if it finds that okay, on the both source and destination, if the configurations are in sync already, or they're all identical or same, basically it does not do anything. So this yellow lines, this yellow color tells okay, it did some changes, or it just syncs the changes, and green means it did not do anything. Okay, now we're all set. Let me just quickly go through. Okay, so we do have our containers running, everything is set, and we are now ready for using these guys to create our 3-node Hadoop cluster. Okay, so we already have copied the repo directory. Okay, so let me we already created. Let me stop this and I will create a second part of it. Okay, so hope you enjoyed this first part, and now watch the second part for the rest of the things. Okay, so in this part basically we had done the installation of the CentOS image. We have installed Docker and Ansible on the CentOS base image. We had created 2 containers out of the image from Docker, that is slave1 and slave2 image, or slave1 and slave2 containers. We have configured both the containers using Ansible. Okay, and now we are all set to install our Hdp2.5 3-node cluster. So hope you enjoyed this first part. Meet with you in the next part.